before I delve into the topic for today, I'll just go through some quick stuff, right? So I'm Obinna. I work at Bev. I also work as a career coach at Udacity, and I like creating music, right? I'm an artist. I also like to read. I listen to podcasts also around tech and basically everything. I also love to paint, right? So now let's get down to brass tacks, right? So first things first, we'll try to understand what version control is. Then next, we'll look at Git, right? Git is a kind of version control and is commonly used, right, across most software and data teams. So we'll look at Git. Then also we'll try to look at GitHub, right? We understand what's GitHub, and how are they different, right? And then how can you use Git and GitHub together, right? And why should you use Git and GitHub together? Then we'll look at some common terms you come across, right? So as we proceed, it will make more sense to all of us. And then we'll try to work on an actual Git project, right? Try to collaborate and see how it goes using Git. So first things first, what is version control, right? So version control, also known as source control, right? It involves tracking and managing changes you make to your software code. So as you work on projects, right, people make changes and you want to track these changes over time. So version control helps you do that. So if you've worked with Excel, you've worked with Word, you've worked with Google Docs, etc., right? There's a form of version control there. So you look at your version history or your version history, right? You look at changes you've made the last 1 hour, last 2 hours and stuff like that. That's kind of version control, right? But then when you use tools like Git, etc., right, you can version control any kind of document, right? So while you're tracking only just the Google Docs or Word, right, with tools like Git and other version control systems, you can track any kind of file and try to look at what's happening, right? So why should you use version control, right? The benefits of version control. So first things first, right? It gives you the complete long-term change history for every file. So version control, right? Once you start your project, you initiate the tracking system and it tracks every change that you make, right? So anyone that makes a change, right, is tracked. What he did, at what time he did that change, right, is tracked. So that way you can try to detect bugs, fix those bugs, right? And as we go on, we'll try to see how that fits into most of the tools we use every day. So next thing, branching and merging, right? So on a software or a data team, right, we might have multiple persons working on a project, right? So I can create a branch or a version of that file and make some changes. And my other colleague will also make a branch of the file and make his or her changes, right? And we can be thousands of collaborators, right? Making our own versions and making changes. And when we are done, we then combine all these changes together, right? And you get the final product. So when you have your apps, right? Maybe let's say your Facebook app, right? Or Instagram app, you hear that there's a new update, right? That's kind of version control. So the current app is still working, but they create a branch, a version of it, and make those changes. When they are done, they then add those changes back and then push it to us as a new version, right? So that's how branching works. Every of our products use some sort of version control. So another thing is traceability, right? So you can trace changes made to your source code. So one thing to note is that when you talk about code, source code, right, is the crown jewel of any product, right, of any data product. The code is the major thing. Once you lose the code for a project, right, you've lost everything because you can't be able to make improvement, can't be able to track what was wrong and stuff like that. The code is the major thing, right? So being able to trace the evolution of your code, right, what was wrong, how we fixed it, what we can improve, right, it's very, very useful. So that's one thing that version control helps with. And then it also enables, insight, measurement, and accountability, right? So as we'll see as we proceed, right, when you use version control in tools like Git, you can look at changes that have been made at one time, at what time they've been made, right? With that, you can be able to estimate how fast or how quick you can be able to solve bug fixes or create new features or stuff like that. It helps you to measure, right? And also ensure accountability of the whole team, right? So you know what you're required to do. And through the version, right, control system, I can see who's doing what at what time and stuff like that. So that's for version control. So if you have any questions, can you put it in the chat and we'll attend to them when it's time for questions. So let's look at Git, right? So what is Git, right? We'll look at version control now. So what is Git? Now, Git is a free and open source distributed version control system, and is designed to help you track changes in your code over time, right? So Git is free and open source. Anyone can install Git and use Git to track his or her projects, right? It's also distributed, meaning that, so there are two kinds of version control systems. You have the central version control systems and distributed ones, right? So distributed means that if we have a central project, right, everyone on the team can make copies of that project on our local systems. So if something happens to the original source project, right, I can easily replace it with my own version and it's safe, right? But with a central system, once the central one is corrupt or damaged, right, then we've lost that project. We need to start from scratch to make it back, right? So distributed means that everyone has his own version, and it enables us to have backups in case something happens to the original one. So in simple terms, right, Git is a tool that helps you track changes in your code over time. So as you make code changes, right, maybe you make updates or you make edits or stuff, you can track those changes over time. So now, why should you use Git, right? So the first thing first, right, we've talked about this branching and merging. So different people on teams can create versions, make their updates, and combine those versions together, right? Then the next thing is what is small and fast. So it's very, very, very small tool, right? So I can just install Git on any laptop and start using Git. There's no large requirements to use Git. And also it's very, very fast. Within seconds to minutes, you can push your updates to your online project repository. Then also it's distributed, right? Like we said, different people on teams can have versions of the central code. So there's backup, right? It's distributed. Then data assurance. So you're sure, right, that the data that's, so the way it works is that we have versions, right? We make updates. When we try to combine these updates, right, you have someone on the team that will review your code and look at what you're trying to push in. If it tests it and it passes the conditions, he now merges it or combines it to the central code, right? So you're sure that whatever is being merged, right, there's a data assurance that is up to scratch and it fixes the problem it's meant to fix. So you have data assurance, and then you have a staging area, right? So this is like once you make changes, you put it to a staging area, right? And then you can now commit these changes to the central repository, and we'll see this in a bit. So lastly is free and open source. So anyone can install Git and start to work with Git, right? So now we've looked at Git, right? Now let's look at some common Git commands that we'll encounter as we proceed with this webinar. So the first one is clone, right? And like the word, like clone, you know, right? To make a copy of something, right? So in version control lingua, right? It means you're bringing a repository that is hosted maybe on a website like GitHub, right? So you make a copy of it and bring it to your local folder in your machine. That's clone. So you're making a copy of a file on an online repository and you're bringing it to your laptop or your system, right? That's clone. Then the next thing is add, right? Okay, so someone asked about staging area as a benefit of Git, right? So staging area is like when you make changes, right? Let's say I'm working on my local folder and I make changes, right? And I want to track those changes. I move my code file that I've changed to a staging area, it means that Git can now track those changes, right? So on a staging area, once I move to staging area, it can now be tracked by Git. The next thing I do is I now commit these changes I made. I give it a description saying that, okay, this change I made is to fix so and so bug. I then push that to the central area. So it's just like or like put it now, it's like a middle layer, right? Before I can push my change to the final repository. So I stage my changes first, and then I give it a description before I then push it to the final repository. So it's just like the middle layer between what you're doing and the final destination you're pushing your stuff to. So we've looked at clone, right? Make a copy of your file. Then you also have, so someone says, does you have a size limitation? So like I said, Git is small, right? And it's fast, right? So I think it's about, when I installed it on my laptop, it's not more than 1 gigabyte. It's less than 1 gigabyte, right? And it's fast to install. There's no size limitation. You can use Git on your laptop. So add, right? So the exact same thing as staging area, right? Once you make changes, you then add that so that Git can track the files you've changed, right? So you add it to your staging area. And the next one we'll look at is commit. So once you've moved your changes to the staging area, you give the description and then you commit those changes. And commit involves adding a message, right, that describes what you've done. So if your colleague is looking at your changes, he can understand what you've done, right? So he looks at the code you've added, looks at your commits, and he understands that, okay, this code is trying to fix this problem or add a new feature or stuff like that. So that's commit. And the next one is push, right? So Git is on your local folder, right? You install Git on your local system, right? You make your changes. Then for you to collaborate with a teammate, right, you have to push the project to an online repository. So on the cloud, online. And that's where GitHub comes in. So we'll come to that in a bit. So for you to push your local project to the online repository like GitHub, right, that's what the push does. So it uploads your changes or your commits to a remote repo like GitHub. That's what push does. And we'll see examples in a bit. Then you also have pull. Now, this is the opposite of push, right? So when you're pushing, you've changed your local system, you want to push to an online repo, right? That's push. For you to copy a file from an online repo to your own system, that's now pull. So you download changes from a remote repo to your local machine. That's pull. Then you also have branch, right? So we mentioned branching and merging, right? So branch means that, so you have this version of the product or software, right? You can now create a version that you can work on. And this does not affect the main version, right? For example, now let's say Microsoft released a new OS 11, right? So if you're on 10, you're on 8, you're on 7, it's still working, right? But then what they did was that while 10 was still working and others were still working, they just made a branch, right? A version of it. And then they made updates, added new features and stuff like that, fixed some bugs. Once they were done, they then added those new updates, right, to the main folder and then send it to you as what? A new version, 11, right? Just like that. Same thing to our apps also. So that's what branching involves. So what's the difference between clone and pull? So Toby, quick question. Do we attend to questions now after everything?
Yeah, let's run through and then attend to questions at the end.
Okay, cool.
Thanks.
So on a high level overview, right, how Git works, right? We'll still look at it practically and it will make more sense. But Git is on your local system, right? So let's say, for example, I can create a new project, right? I start to code or add files. Once I've made changes, right, I then add those changes to a staging area. This now, so in this first stage, right, Git is not aware of what my files, right? It can't track it yet. Once I make my changes, I then add it to a staging area. Now Git can track that file now, right? It's now aware of what the file that I've updated. Then once I put this staging error, I can then commit this, right, to my project repo. So the first thing you do, right, is you first create a repo and then you use Git init, right? So look at that practically, but that's how you go about it. You first create a repo and then you initiate that repo to enable Git to track it. So it's empty. Then you then start adding files. You start coding, maybe SQL codes, Python codes, etc. You add it to your files, right? Once you add those, make those changes. So you don't add several changes, right? Just change step by step. I might add one part of code that solves one problem. I add it to my staging area and commit it. I give it a message. This line of code helps me to fix bug A. Then I add another line of code also, right? This helps me to fix bug B. The same process also, right? So this Git, right? This is still locally on my laptop, right? I've not yet moved it to a remote repository yet. That's what Git does, right? It helps you just create your repo and manage your files on a local instance of your system. So now let's go on to GitHub now, right? So GitHub is an online software dev platform used for storing, tracking, and collaborating on software projects. In simple terms, GitHub is a website, right, that helps you to manage your projects, right? So you can host your projects on GitHub and have people collaborate with you, right, on this project. You can track what changes they've made, etc. So it's an online website that helps you to manage your projects. Also, is a social networking site, right? You can connect with other developers or programmers, right? So you can look at what they're working on. You can try to, so in GitHub terms, what we call fork, F-O-R-K. It means I can go to any public repository. I'll copy that into my own GitHub folder. When I make changes to it, I'll then send my updated file to the owner of that repository I copied initially. He looks at my changes. If he accepts them, he then merges my changes to his own, right? So that's how open source tools, right, like Python, Java, etc., right? That's how they get better, they update, right? So it's open source. Anyone can go to Python's GitHub repo and fork the repo. So maybe I'm trying to code on Python. I see a bug that's affecting me. I say, I want to fix this bug. I just go to Python's GitHub repo. I fork the repo, right? Take it to my own. So when I fork the repo is on GitHub, I then use my Git to clone it to my local repository. I try to write code that helps fix that bug. Once I've tested the fix that it works, I'll then push my new change to GitHub, right? And now I'll then send a request to the Python developers that maintain the repo. Hey, check out this change I made. I'm trying to fix this bug. So on their end, they'll test it and see, oh, this makes sense. They then accept that change. And after they've seen enough updates, they will then push a new version 3.9, for example. This fix XYZ bugs. That's a collaboration of several people that have sent codes that fix different bugs, right? So that's how version control works, right? GitHub, Git, etc. So on to the next slide, right? Why GitHub? So first things first, right? Enhanced collaboration. So why you use Git on your laptop, right? I can't collaborate with anyone because it's on my local instance. But when I then add Git with GitHub, right? So it's like a connector. It connects I and other developers. We can now collaborate. So I create a project, put it online. Toby can copy that project, make changes, update that file online. Someone else can copy that project, or just like that, right? So that's how GitHub works, enhanced collaboration. Then also easy file management, right? So you can track changes, right? That Toby made, I made, other team people, you can track everything and you can be able to detect bugs, etc. Then social networking, right? You can network with other developers, see what they are working on. And if you've applied for some dev jobs, right, you find out that they ask you to send your GitHub profile. So they go to your GitHub profile, they look at what you've done, look at your codes, your projects, and if it makes sense, they just say, okay, this guy is good, we'll recruit you, right? So it's a way to network also. And also it's kind of a place to display your work, right? to have recruiters come look at your work and see if they can recruit you. Also, you can create private repositories. So private means that only you can have access or see that repository. No one else can. So you can create a private repo and build your personal projects there that you don't want to share. Then also open source projects. So like I mentioned, right, Python, etc. They have open source repos on GitHub. You can fork this, make changes, and send to them to review if they want to accept it. So one common instance of GitHub, let's say for example now, I'm a dev guy, right? I'm trying to create a game, create a new game, for example. So I reach out to my friend, Toby, right? Hey, Toby, let's collaborate on this game. I share my ideas with him. He said, okay, let's work on it. So I create a repository and then I add Toby as a collaborator to that repository. So we share the work, right? I will build the main game this thing features. Toby will work on the UI UX, for example. So once I create a repo on my local instance, I will just push that repo to GitHub and then add Toby as a collaborator. Toby can then clone that repo and also create, he can work on his own laptop too, right? With that version on his laptop. I work on my version also. Then maybe example, John, right, is scrolling through GitHub. He then sees my repo. Oh, sees the project. And he looks at the description. He likes the idea, right? And the good thing with GitHub is that you display everything, right? The codes, everything they are there. So I can see what it's about, look at the codes and everything. So John now says, I think I can add some new features to this, maybe a multiplayer feature. He then forks this project to his GitHub and clones it to his own repo. He can now start creating a multiplayer feature on his own site too. So on my end, I'm working on the main game features. Toby working on the UI UX. John working on the multiplayer, right? When we push our changes to this thing, to the GitHub repo, and we merge everything together, we now have what's a game, right? That has good UI UX, main features, multiplayer, right? The same way also, you can keep improving that game, right? We create clones, make changes, right? Branching and stuff like that. So we'll see a small example, right? But this can really scale to thousands of people collaborating on one project, right? And that's one good thing with version control. So some common terms that I might mention as I go through the demo, right? So you might hear something like directory or folder, right? This is simply what a folder on your laptop, your local laptop, right? A directory or folder. Then you hear terminal or command line interface. So this is a way for you to interact with your system, right? Using text commands. So you have command line interface, you have graphical user interface. If I want to make a new folder, I go to my folder, right click, right, new. That's a GUI, GUI, graphical user interface. I need to click things for my laptop to respond to me. But with command line, right, I'll just open my terminal. I'll type in text, right? And the shell will interpret this text, send it to the laptop, and it will give me the results. So I can do the same thing. I can make a folder, right, with the command line interface by typing text instead of using the graphical user interface. So that's a terminal. You also have code editors, right? So code editors, right? These examples are things like VS Code, right? Atom. They also help you to work with your codes and stuff like that. Then repository, right? This is a project that you host. So I think I'll share this file. You can go through all the stuff. These are command line sheets. These are Git sheets, right? So you can look at this, look at commands and stuff like that. So this is a picture of how Git plus GitHub works, right? So on my laptop, I create my folder, right? Make my changes, stage them, commit them, and push them to GitHub. Someone else can fork my repo, make his changes, right? And push it to GitHub also. So just like that, that's how it works. So let's go through a quick demo, right, using Git, right? So first things first, right, install the version of Git, right? This is a link. So git.sm.com. So if I share my screen to this, I'm going to share my full screen. If I come onto this URL, so git.sm.com, right? This is where you can download Git. So you see different OS, Mac, Windows, Linux. So you just click download and click on the downloaded file, right? Run through the commands. That's all. You have Git on your laptop. Then the next thing you want to do is so let me see. So after installing Git, right, then you go on to GitHub, right, and make an account. So I'll just show a quick view of what GitHub looks like, right? So github.com. So I'm already, okay, sign in. Let me see about the sign in, right? So if you look at create an account, right? So you can make an account, right? You come in here, just the same thing, right? You come to GitHub, you put your email, continue, create a password, etc. And you're onto GitHub. So I can just sign into GitHub, right? I'm signed already. I just put in my details and sign in. So this currently is my so this is my dashboard, right?
I think you're not sharing that GitHub screen.
Okay. Apologies. Let me share my full screen. So let me go to this again. So I come on here. I'll just log out and do this again. So I sign up. So you come on to GitHub, right? You're coming for the first time, you need to sign up for GitHub. So you put your email address, you sign up, right? You create a password, etc. Once you're signed up, you can then sign into GitHub. So I'll just put my details here and sign in, right? And you can see my profile and my repositories that I've worked on, etc. Right? So let me just open the sample one. So on the repo on GitHub, right, you have what we call a README file, a description of what it's about, right? So you see text, what this project does, how it works, etc. So it's up to you to make it look like how you want to make it look like. So you put all those details there. And let's say someone comes across this project, right? He wants to recreate it. Then you come on here, this icon here, right? Fork. So you fork this GitHub repo, and then you can then clone it to your repo and try to recreate it or make updates to it, right? That's a fork option. So if you want to make a new repository, right? When you come to this drop down here, you'll see, sorry, this plus icon here, right? I can make a new repo, right? So I'll call this repo, this is for our demo. I'll call this RESA cases, yeah. And can give you a description optional, just keep this. And you can add a README file, right? But I'll just skip this for now. So a README is just, like I said, right? Gives a description about your project, etc. You can put a license too. So I click on create repository, right? And this is called RESA cases. That's the name of the repository. So currently the repo is, this is empty, right? I can make a new file. So I'll click on this, I can make a new file. And I'll give it the name, a readme.md. Yeah, readme.md, right? And I'll add description. So in GitHub, right, when you're making readme files, there's a language called Markdown. It's used to like create things like notes and stuff like that on web interfaces. So if I come on here, I just put a hashtag. This is like for a header. So I'll call these cases tracker, right? I'll add some text. This repository helps resolve ad hoc cases for the sales team. Just simple like that. That's all. So I come down here, right? So for GitHub, right, everything is abstracted. You don't need to stage stuff. Once you create your file, right, you just come on here and commit immediately. So you can put in your commits. This is already auto-filled, create readme.md. Or you can add yours if you want to. Then add a description also, and then commit new file. This means that I've made changes, right? And I'm saving these changes. Anyone that sees this stuff now will see the change, right? I made a readme file. So I commit this new file here. And you can see this is now updated, right? And you see the text here, cases tracker, this helps resolve cases, etc. So you can make it more descriptive, right? But because of time, I'll just leave it like this. So I've made this change, right? And you can see here, this is the commit I made, commit, right? So Obinna at this time, right, made this change to this stuff, etc. And you have this code, right, that is unique, that shows the commit I made. So now this GitHub, right? Let's say I want to make more updates to this project. I want to add files, etc. So just just to give more info on these, right? Let's say currently at this company, right, Reza company, right, we're trying to help the sales team, right, resolve their ad hoc requests, because in the meantime, we are trying to migrate data to our data warehouse. That's ongoing, but we need to be sending them updates on their requests that they are sending to us, right? So on this place, we try to track and add the files we send to them. So it makes it easier for us on the team, right? We can add the cases we resolve. We put the code files here. We put everything, the tickets, number, everything. So if it comes up again, someone can just come here and reuse the code instead of doing it from scratch, right? It helps us to just track all the cases we resolved. That way, if a case comes up again, I just come in here, get the code from the case file number and use that to solve the request instead of building from scratch. So this is my repo online. I want to clone this now to my Git, right, on my local instance. So if I come onto this drop down here, code, you see this clone option, right? You can clone via HTTPS, SSH, or GitHub CLI. So I come on here, I'll copy this URL, right? Copy this URL. So now, let me open up I'll use VS Code for this. Open VS Code quickly. So I mentioned using what was it now? Using GitHub, right? Then install a code editor, right? VS Code or Atom. So currently I'm using VS Code, right? But when you just go online, search for VS Code install or Atom installed, you'll see these editors. You can use this to run your codes, several different languages, right, etc. So I've opened my VS Code, right? Let me close these files I had previously. Just close all these files. Yeah, cool. So here now, I want to make a new project, right? I want to clone my repo. So I come on here and I make a new folder called RESA cases. So a new folder. So I call this RESA cases. And on here, this is where I'll try to clone the repo into, right? My repos folder is subfolder called RESA cases. So I come to terminal, right? And open a new terminal, a new one, right? So Git, right? It runs to the command line interface, right? For Git, it runs to the command line interface. So let me see. Command line interface, right? So here you use Linux commands, right? CLI commands to do stuff. So for example, I can run commands like ls, right? This is a CLI command that tries to list the files that are in this current directory. These repos, right? So enter. So you see, it shows me what's currently there's a folder called RESA cases here, right? You have another command called cd, right? It means what? Chain directory. So I can move into a directory. So cd, right? I want to move into the folder called RESA cases. So I enter, right? And you can see currently now I'm on RESA cases, right? And here now I want to clone that repo from GitHub I copied. So the command git clone, right? I'll type that and paste that URL. So once I have this, I can hit enter. So you see these options that come up, right? I'm going into this repository and
Obinna,
yeah.
just to be sure, you'd need to have Git installed, right? The software installed
Yes,
before
yes.
being able to run this command, right?
Yeah. So the first thing we did was to install Git, right? I didn't go through that because I have it already. But once you install Git, right, and have that installed, then you can run Git command, right, and it works. So here I try to clone from GitHub, right, into this, and because I'm using an online repo, right, to start the project, there are things that I wouldn't do. If I was using my local laptop to start the project, I will need to first initiate a Git instance on this repository. And then I can now start creating files and Git can track them. But because I'm copying a file from GitHub, right, then there are some steps I'll skip. So I've cloned the repo, right, and now you can see that it gave me some output, right, and it said that this is done. It's gotten the objects from the repo. In this case now, that should be the README file, right? So I'll come in here and I type in ls to list the files in this repository. So Reza cases. So I seed into, so this now is the same folder, right, on my GitHub, the same file on GitHub here. That's the exact same one. All right. So this same project, Reza cases, right? He made a new folder called Reza cases. That's what it's showing on that place now, Reza cases. So this is the same folder. He has copied it, right? So let me go into this Reza cases folder now. See the Reza cases. So I'm now inside the repository I cloned from GitHub. This is the folder I just made now on my laptop, right? But now I've cloned this repository from GitHub into this folder, right? So I think I use the same name, but that was an oversight, but let's just go on. So now I'm inside the repo from GitHub that I cloned. I can do ls again, right? List the files inside here. And now you see the README file, right? The README file that I made on GitHub. And when I open this folder now, you see the README file, right? Click on this. The exact same thing I typed on GitHub, right? Case tracker. This repo helps resolve cases for the sales team, etc. Right? So because of time, quickly, right? So let's say we have a case that came in, right, from a sales agent. So he's asking us what, help us with the name of the clients in this, help us with the name of the sales rep in each region with the most amount of sales, right? Secondly, for the one with most sales, right, how many others were placed, right? So I'll try to resolve the first one, right? And then I'll have my colleague resolve the second one. So let's see how we can walk through that. So if I come on here, right, I want to create a case file now for this particular ticket that came in, right? And it's called CA001. So I come in here, right? So like I said, you have your GUI. I could come to this place, this folder, right, and just type what plus, make a new file, right? And I'll give it a name and save it. That's using the GUI, right? Clicking and getting your output back. I could also do this also with the CLI, right? I could make a file with the CLI. So if I come on here, there's a function called make directory, right? Make directory. So I'll call this CA001. I'm making a folder called CA001, right? And I enter. So I have this now. Let me see. So CLI, yeah, that's command line interface, yeah. So I've made a new folder what's called CA001. And if you look here now, you can see that what is created, right? CA001. Now I want to create the SQL file that helps me to resolve this case, right? So basically what I did was that I would have written my code, run the query on the database, right? Get the outputs. I'll then include that with the results, right? And send it to the GitHub folder. But now I can't do that because of time, right? But that's the idea. So I've done my query on the database, gotten my data and the SQL file. So I come on here, right? I want to add that SQL file here now and push that to GitHub. So my colleague can then copy the same file and add the second result to that also. So I come on here, right? Currently I'm on Reza cases. I want to come into this folder, CA001, the same thing to write. I will cd into this, cd change directory to CA001 and enter. So now I'm here. Now to make a file, right? SQL file. So echo, that's a command to make a file. If you're on Mac or Linux, then that's touch. So I'll share my PowerPoint slide. I have a cheat sheet for all the stuff there. But echo means I'm making a new file, right? And I'll put a full stop just to put something into the file. And I'll call the file ca001.sql. So you put a sign, right? So I'm saying create a file, right? And add this dot into it called ca001.sql. And I enter. So if I open this file now, you see a new SQL file has been created, right? SQL file is now here. And currently it has a dot inside it, right? It's currently empty. So now let's try to use Git, right, to track these changes that we've made and then update it and stuff like that. So in SQL, right, in Git rather, you use a function called git status, right? Git status. It helps you to what? Return the status of your repo. So when I enter this now, so you said on track files, right? So you said currently my branch is up to date with origin main. This main simply refers to my GitHub repo I copied from. That's a nickname for it, origin main, right? It's now saying that what I currently have an untracked file, which is what this SQL file just made now, right? So what I can try to do now is I'll try to add the staging area, and that's why you now have git add. It adds the file I made, ca001 staging area. So now Git can now track that file. So when I say git add, right, I can put in the file name, or you can put a dot, right? It means add everything, or you can put the file name to add just that file. So when I enter this now, and I type git status again, right? You now see what Git can now track that SQL file you made now, right? So it's saying that what I can now track this SQL file, ca001.sql, right? Next thing now, I need to commit this change, right? So I come on here, git commit, right? This means what? I'm pushing this change now what? To the local repo. And commit goes with a message. You have to describe what you just did, right? So I put a message, right? -m, that's a command. So it means make a message, right? And I'll call this, I created ca001.sql, right? And I enter, right? So it gives a feedback, right? That I've changed one file on this repo. So now if I come here and type a command git log, right? This shows the changes I've made so far, git log. You can now see what's one file change, right? And you have a commit number. This is unique for every change you make, a commit number. You have the author, I made the change, right? You have the date it was made and the time. And this is the command, right? The text, I made this file, right? So one thing I want to do, I can come here and add the SQL file code I wrote, right? So let me just do that quickly. So I come on here and copy the code I wrote. So there's a code, right, for question 1. It solves the question. So I'll put that here on my SQL file. So I take off this and add this here, right? And save this. So I've made another change now in this repo, right? If I come on here and type again, git status, right? Enter. It says that what I've made another change again now. I've changed the file here, modified, right? So I've made a change to this file, and Git can notice that. The same drill also, right? You add this git add and a dot. So I add this to the staging area, and this again now git status, right? I enter. You can now see what's Git can now track this file now, right? Modify this file. It's now in green. Git can track it. The next thing I'll do now is to commit this, right? Git commit -m. Now put a descriptive message, right? So I say added or add code to resolve tickets ca001. So this way, when my colleague sees this, he knows what I've done, and he can be able to continue from where I stopped to finish the ticket up, right? So I enter this stuff, right? I've changed this now. The next thing now, I want to push my changes now to GitHub, right? Remember on GitHub, what we have on GitHub is just a README file, right? A README file. This is not there yet. So I'll push this now to GitHub, right? And for that, there's a command called git push, right? You need to add some stuff. So when I do git push now, I will get an error. So I'll get an error back. Let me see what happened. Okay. What happened was that I'd already initiated this previously. I think it's pushed to GitHub. Let me see. Yeah, git push to GitHub. But ideally, right, if it's your first time doing this, you have to put git push, and then you put a command remote origin, and then main, right? So I'm pushing to a remote folder, and this is the alias origin on the main branch. But I think it's worked. So when I go back to GitHub and check what's happened, let me see. If I go back to GitHub and check, when I refresh this, I should see some changes. So you can see previously we had a README file now, but we now have a folder added, right? CA01. And when I click on this, you see the same name I give to you, right? Add code to resolve tickets. And I now have 3 commits, right? The first one was done by me on GitHub, made a README file. I then did this on my local folder, SQL file, create it and add the code. It's now here on this, right? So now from our ticket, we have 2 tickets, right? 2 tickets, 1, 2, to solve, right? I've done the first one. This for my colleague now to resolve, right? So I'll come on here and add my colleague as a contributor to this repo. So I come to settings, collaborators, right? And add people. So my colleague is called Oluwatobi Williams, I think. Yeah, this. So I add him to this repo, right? As a collaborator. So I'll send this to Toby, the invite to Toby, and have him join, have him clone this. So
yeah, I received the invite.
Yeah, saying so, you know. So Toby, you get an alert on the side, right? That I've added him as a collaborator to this repo. So once he gets the invite and accepts it, right? So I think you can share your screen, Toby, to show what you have.
All right. Let me share my screen. Yeah, so I've just been added to this Resa cases repo, right? I think I can see the exact commit and the SQL code and the tickets as well. All right. Okay. So what do you want me to do now? I should clone this repo, right?
Yeah, exactly. Yeah, clone it, and then you try to add the code for the second question. The ticket is in 2 places, 1 and 2. So you do the second one and then push that also to GitHub.
Okay. So for me, I'm going to clone this using the GitHub desktop, right?
Yeah, so to add to that, right, you have 2 ways, right, to work with this. You can use the CLI, that's Git. You can use a GitHub desktop. That's an app also. Yeah, so I have a question. How do you tell him via GitHub to work on a ticket? Yeah. So what I'll do in this case, right? I'll create a branch, right? I'll create a branch of my current repository. And then on that branch, I'll make these changes, right? In that case, I can then add a comment, right, to Toby. So what happened is that Toby now will do the same thing, right? He will add a comment to me to tell me a particular thing. So that's the exact same thing you can do. You can create a branch. When you push that change, you add a comment, right, on particular lines of codes, telling me that, okay, when you're reviewing this code, check this, check that, and stuff like that. So I think it's best, Toby will show that to us once he's trying to push his change, right? So currently, Toby has cloned the repo, right, using GitHub Desktop. This is a different tool. You can use that to clone this repo, right? So he's made the clone, and you can see the exact same thing on his laptop, right? CA001, the README file, etc. So Toby now will try to create a new SQL file, right, where he will add the code for the second stuff, and then
where do you want me to put the code? Inside this folder, or?
Yeah, I'm coming. Yeah. So yeah. So in the same folder as that one, you just create a new file and put a -2 at the end.
Okay.
Right. And then you then, so
without bringing up, will I be able to check these from VS Code here? Yeah,
you can. So if you want to, you can also do that manually, right? Go to the folder, right click, right, make a .sql file and paste the codes there, right? But that's not advisable, right? It's best to just use either the VS Code, right, or you use the CLI to create the file and then update it there. So here, yeah, exactly. So you can.
And would you want me to create another branch, or should I just create the new code here?
Yeah, you can make a new branch.
Okay. So I would have to do that from within here.
Yeah, you can use VS Code. You can also use GitHub Desktop, but let's use the desktop, right? So on the desktop now, right? So just to introduce what branching means, right? Like we said, so currently I'm working on the main one, right? So he wants to make an update. He then creates a branch. So he can make his updates and then send a pull request, right? A pull request means that I've made changes, compare it and see if it makes sense. If it makes sense and is correct, then add that to the main file. So currently he's making a new branch, right? And he's called that branch CA01-2. So he creates that branch now, right?
Okay.
Yeah, exactly.
Then I can create another file under this folder, right?
Yeah, a new file.
Will this then be ticket 2?
Yeah, and you can call it that. The SQL, yeah.
Okay.
That's a file. So you paste that the code, right? You've written to solve the problem.
I think I have a copy of it.
Yeah, check the chat. I think I sent it to you now.
You sent it to me now. Okay, let's have a look. All right. Okay, so this is the SQL code. I'll save it, right?
Yeah. So then you'll save. So wait, don't save. Are you saved?
Yeah, I just
saved. Okay. So go back to GitHub Desktop now. So you can see you now have a new file, right? CA002.sql, right? And you can see the green icon at the right hand side, right? Showing that I've made a new file. It's a change, right? So currently this is a new branch, CA01-2. Toby, can you go back to the main branch, right? Change the main branch. Switch branch, yeah. Yeah, leave my changes here. Leave my changes there. Switch branch. So if you look at the history, right, this is the exact same thing that I did on my side. I pushed to GitHub, CA01, SQL, etc. But now Toby now made a new branch, right, a new version, and updated something there, right? So can you go back to the branch now that you made? So that has the exact same thing that was here, these 3 commits, but with an extra one now. So you now have you're on the new branch now, right? So when you go to history now, you should see the new, okay, you've not committed yet. So he's made the change, right? He's now stage. He needs to commit the change now. So when you click on commits down there, Yeah, restore.
Maybe I need to restore this, right?
Yeah, restore.
Then
yeah.
I can commit.
Then commit this now. So you now make the change. So you put a text, right? Added code for CAO to the SQL, that kind of thing. Added code for tickets, yeah. CAO to stuff like that. Yeah, then you can commit it now. So when you check your history now, you now see an extra commit, right? Made by Toby. The first three are made by me. The last one made by Toby, right? So just one more time, just go back to the main branch. Let's just compare again. So when you make changes to one branch, it doesn't affect the other one. This is still how it is, right? This is what I did, right? Toby now made a copy now, right? A new branch and made an update. So now he'll push this update back to GitHub and ask me to review it. I can then merge it now to the final version. So we'll have the end goal we're trying to achieve. So once you have this now, right, you now publish it. So with GitHub Desktop, right, it's different. On VS Code or any editor, I will type some kind of code to make this happen, right? But this GUI just makes it easier somewhat. So push this change now, publish the change. Yeah, exactly. Yeah, exactly. So he abstracts most of the codes that you write, right? So it just has Git inbuilt and does everything. Yeah, exactly. You don't need to write all those codes again.
Do you want to show how it shows at your end now? Should I stop sharing?
Can you go on to GitHub first? Go on to GitHub.
Okay.
So you've pushed your change now, right? You've pushed your change to GitHub. So now this is what it's showing now, right? It's showing this view. Toby has made a change. Now, on my own end, I won't see this stuff, right? Until Toby now clicks that icon to compare and pull requests, right? Once he now pulls that request, on my end, I will now see his request, right? Then I'll try to be able to review it and then match it to the main branch. So here now, reviewers, right? He'll add my name now as a reviewer, right? Obinna. And then on this place, right? We can decide to add a comment, right? To tell me what he did, right? Etc. Blah 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 blah. And then create pull request. So let me share my screen and show you what I have now. So if I come back to Reza cases, right? So currently you see what it's showing here, right? But if you look here, right? Can I zoom in? So if you look here, you see this stuff. Let me annotate, right? Quickly because of time. So you see this stuff here, right? Pull request. So what we just did now is a pull request, and you see what there's one pull request, right? There's one pull request that's coming. So I'll click on this pull request now and review it. So currently, this is what I just did, CAO1, CAO2. But I'll look at Toby's pull request and review it, right? So I see one open request, right? Added code for ticket CAO2. So I open this up. And here I can see the comment, right? Obinna, please review this code and match with the main, right? So this is review requested, etc. So I can come on here and click on the commit, right? And I can see the code he wrote, right? I can review it. I can copy this code, go to the database, run it, test it. Does it work? Yes, it works. Okay. I then come back here and I'll try to accept the pull request, right? So I come down here. Once everything is fine, right? I come on here and match the request. So I click on match pull request. But I can reject it and give him feedback, right? If I want to. I click on match request and then confirm the request, right? So once I confirm this request, right, it's merged and closed. So most times when you merge a branch to master, right, you just end up deleting that branch. Since you've made the changes to the main branch, you can take off that branch, right? So I take this branch off, delete the branch off. And then when I go back to other cases now, I've added Toby's change, right, to this. If I open this folder now, I will see Toby's file, right? That I added CAO2.sql, right? So Toby added this code here, right? the SQL, and I can see the code here sent to me now. And then, so you can come on here and check the commits that have been made so far, right? 5 commits. 1, 2, 3 are made by me, and these 2 are made by Toby. So you can track all this stuff, right? So there's no time. I've gone through branching using the CLI, but because of time, we'll just keep that. So just go to Git branching, right? You see this tree here, right? This is what commits look like when you're branching. So the stuff in purple, that's a master branch. Green, that's a feature branch, right? The purple stuff now, right? So let's say I made one commit, made a change in code, a change in code. At this point in time, my colleague Toby then comes, he clones this repo and makes his own updates, right? 1, 2. While he's doing his updates, I'm still working on my main branch, right? I made one more commit 4, right? Then as we go on also, I can then notice that, here's my keyboard though. So after Toby has finished doing his updates, right, he comes to the final place, right, and merges his updates with my main branch, right? So that way, all the stuff that he's done, right, he now adds that to the stuff. So this is how they fix bugs in apps, right? At this point in time, right, maybe you have a bug that is affecting the consumer, they are complaining. So we are also adding new features, right? And making a new feature. But Toby made a version here and try to fix those bugs. Once he's done, he then adds that bug fix. I made a new feature with the bug fix. I then push that a new update on the app, right? Just like that. That's how it works. Then also, you can also make branches, right, within your. So I'm working on this, right? I come on here also. I see another bug. I can make a new branch and fix that bug and also add that to the main branch, right? Just like that. So it's a very, very can get very complicated, right? But that's how software teams work, branching and solving fixes. So I've added some resources to learn Git, right? You have a free Elastic course, documentation, etc. And also you have Markdown, right? This is how you create README files. So Markdown, you can go through this tutorial, very interactive. Then you have Shell Workshop to look at those Linux commands, right? Echo, etc. that I went through. So because of time, right? I have more to go through, but we'll just stop here because of time. So I think we can go through any questions you might have.
Obinna, that's really, really super. Thank you so much for such an exciting presentation and practical session. I think we, including myself, all learned through that. And very quickly, we'll go through the questions. The first one I can see here from Chukwebuka is, why would someone use a central version type over distributed? Is there any advantage? Because it seems scary in terms of replacement when you have bugs and crashes.
Okay.
And yeah. And I think the second one here is, what's the difference in clone and pull? I think we covered that, but yeah.
Okay.
Maybe
so for the first question, right? So the first version of version control systems, right, like CVS, etc., they were central repositories, central version systems. They are popular at the time, right? But then with the advent of distributed systems like Git, etc., right, you find out that the pros for distributed, it outweighs the cons, right? Is more robust and is better than the centralized versions for the obvious reason, right? Centralized, once there's an issue with central repository, then you lose all your data. But with distributed, you have copies and backups everywhere. So that's why Git is popular, distributed, right? Compared to the old central version control system. So I think that's a major reason, and it's advisable to use Git and its likes because of that feature, it's distributed, and you have data assurance and stuff like that.
Okay, and difference in clone and pull very quickly.
Yeah, so for clone, right, is essentially copying the contents of an online repository to your local repository, right? You just make a copy. So example, like what I just did, I created a repo on GitHub. I then cloned that to my local repository. I made changes and pushed that back, right? Then for pull, right, Git pull. So for you to use Git pull, it means that you have a connection to a remote repository for you to pull changes, right? It means that, for example, I copied my GitHub repo to my local system, but then my colleagues, they've made some changes on the online repo, right? For me to stay up to date, I have to pull from GitHub to my local system to stay up to date. Then I can then push my new changes to GitHub, right? So pull is just essentially, there's already a connection between the repos, right? You have some of the files. You want to stay up to date, you then pull the files. But with clone, you're creating a new project. You're bringing the repo from GitHub to your Git system on your local instance. There's no connection prior to you cloning the repo. So I think that's the major difference.
Exactly.